Hey everyone, I am Priyanshi Agarwal and welcome back to my YouTube channel. Now we will be solving today's Leetcode daily challenge, which is making a large island. So let's see what is this question and how we can solve it. So in this question, you are given an n plus n binary matrix grid and you are allowed to change at most 1 0 to be 1. Okay. And we need to return the size of the largest island in grid after applying this operation. And what is an island? An island is a four directionally connected group of ones. Okay. So these are very small examples like just 1 0 0 1 1 1 1 0. So it would be difficult to explain this question in these examples. So let's take a little bit bigger example. Okay, so let's say we have this grid which contains these islands and the rest of the indexes are filled with zeros. Okay, so what we can first of all, how we get to know the size of the island, like uh, how many number of ones it contains is equals to the size of the island. Let's say here it contains 7 ones, so the size is 7. And here, let's say in this red island, it contains 8 ones, so the size is 8. Similarly for the other islands too. Okay, so now we need to find the size of the largest island. So right now, what is the size of the largest island? That is 10, right? But what we need to do, what we can do is we can convert at most 1 0 to 1 and then see if we can get the size of the maximum island. Okay. So let's say if we convert this one, so first of all, how we get to know the size of these islands, how we will count the ones in these islands. So we can simply do a simple DFS or BFS traverser and simply count all these ones in all the islands, right? So by doing a simple DFS traverser, we can find the size of an island. Now we know this thing. Now we can convert 1 0 to 1. Okay. So let's say if I convert 1 0 to 1, and then again, we will need to compute the size of all the islands in our grid. So let's say if our grid is of n into n size, let's say n square, and we are iterating in the complete grid for changing 1 0 to 1, 1 by 1, and then computing the size of the island every time we change a 0 to 1. So how much time we get computing the size of island we get? N square, right? So this will ultimately become n4. Then so let's look at our constraints. So n is 500, so it will be around 5 to power 4 into 10 to power 8. So obviously this is not a good complexity to solve this question. Okay, so what we can do instead of doing computing the size of the island every time. Okay, so let's see. So let's say if I am changing the one here, right? So the size of the islands which are present at this position, at this position, at this position, at this position will get added, right? Because if we change, because what is an island? Island is a four directionally connected ones, right? So if we change the 0 at this place to the 1, then the islands at these positions will get merged into this one, right? But right now there is no island in all the four positions. Okay, so let's try changing the 1 at this position. Okay, cool. Now the islands at this position will get merged because we have changed this 0 to 1, right? Okay, so let's say instead of after changing 1 0 to 1, instead of taking in the complete grid, we will only compute the size of the islands at these in these four directions. But it will still remain n square because we are doing the DFS again and again for each index. So what we can do here is we can use a pre-computation technique. How? So let's say, okay. So let's say if I have computed the size of this island, which is 8, and by computing the size of the island, I have given it a color red. Let's say for now red. We will see how we will give it a color, but for now let's say red only. And then I will give this island a blue color. I will this island give a yellow color, and this will be of white color. Okay. So now let's say if I am changing this one here. So what I will do is, let's say, I will check. Oh, in the top of this one, there is a red colored island. So I will do 1 plus 8, which size is 8. And in the left of this one, there is a blue colored island, which size is 7. Okay. And in the right and the bottom of this one, there is a yellow colored island. But we will count it only once because this those islands are of same color. It means they are stretching to both the indexes. And the size of the yellow island is 10. So our overall size will become 26. Right? So what we have done is we will do a pre-computation of all of the island size so that whenever we are changing a 0 to 1, then we can simply check in the four directions and add those values to get the maximum size of the island. Now we have understood the approach. But the thing is, how we will do that pre-computation? Okay, so let's see how we will do that pre-computations. Okay, so for doing the pre-computation, we can create a vector of island size, right? Let's say the numbers will be the colors. Let's say 0, 1, 2, 3, 4, 5, 6, and so on. But as the matrix is prepared with zeros and ones, so we will not take them into consideration. We will start the colors with 2 and 2, 3, and so on. Okay. So that's a while computing the size of this island, or we can say by doing the DFS, we can simply change these values to 2 so that this will become the island with the color 2. Cool. And similarly, we will store the size of the island corresponding to that color, which is 8. And similarly, for doing this widening for this blue island, we will change its color to 3, 3, 3, 3, 3, 3, and 3. And we'll store its size at the index of this color. And see, this island size vector will also work as an visited vector widening the DFS. Because if value at that index is not 0 or 1, it means that is already visited, right? So this will also work as a visited vector. Now similarly for this yellow island, we will assign a color 4, 4, 4, 4, 4, 4, 4, 4, and 4. And we will store its size here. And similarly for this vector, we will assign color 5, 5, 5, 5, 5, 5, and 5. And we will store its size. So for now, this is our vector 8, 7, 10, and 8 from the index 2, 3, 4, and 5. We will see like how we will manage this from index 2. And see, don't like it might be not be a good practice like we are changing the grid here, but we will use a copy of grid vector in our code. But here it's not a very big issue because we can retrieve our input data because all the values other than 0 can be changed to 1. So we are not discarding our input here. We can retrieve it also. But in the code, I will create a copy of grid vector, so we will not be changing the input in our code. Okay, so now you have understood that how we will be managing the colors of these islands. So let's say I have changed the 0 at this position to 2. So we will check in all the four directions of this one, and then we will see, oh, it's a 2. So we will check the size here 8. So we will add this one with 8, and we will check in the left of this one. Oh, it's 3 color. So its size is 7. Okay. And in the right and the bottom is 4 color. So its size is 10. Oh, cool. Now we have got the size of our maximum island. Right. So let's see its code so that we will get a better idea. Okay. So first of all, in this, here is a function largest island. We will store the size in the m and m as it is an n plus n, so we don't need to store again, but I am saying it mostly. And then we will create a copy of grid, so we will not be changing the input in this example. And we have initialized the iron size with 0, comma 0. So that 0 and 1 index are discarded. And now we will start with the second index as we have seen in the diagram. Okay. And then we will iterate in our complete grid. And then we'll see if it is 1, only then we will do a DFS traversal. Because if it is 1, only then it can be iron. No? So that's why if it is 1, then we will do a DFS traversal. Okay. Now see, our initially now here our iron vector is 0, comma 0. Its size is 2, right? So now the current iron which we need to fill the from which value we need to fill the current iron, which is iron dot size because the current size is 2. And then with any value if this is filled, then its size will become 3. In the next iteration we will send 3. So in the next iteration the iron will get filled with this 3 value. So in this way we are managing this. We are handling the color from which we need to fill our iron. Okay, so we have simply sent the copy grid and the value with which we need to fill the iron and the row and the column. And whatever value, or we can say whatever the size of the iron that the DFS function will return, we will simply store that size in our iron size vector, right? Yeah, because we are storing the size of the irons in our vector. Now let's see the DFS function. So this is a simple DFS traversal. This is the base condition. If the row and column goes out of bounds, or if it is not 1, then return 0. Otherwise, change the value to the current value, which is a color, and iterate in all the 4 directions. Right. So in this way, we have created our iron vector. Now what we need to do? We need to change each 0 to 1, one by one in our grid, and then check for all the 4 directions, and then correct the unique colors in the 4 directions and add their sizes, right? So here see, we are iterating in the grid. If it is 0, then we will change it to 1, and we have created a unordered set unique neighbors. So we will iterate in all the 4 directions with these dead row and dead column vectors, and we will take the row and column of all the 4 directions, and we check if they are under bounds. Then we will simply store the color of that iron. So in this way, we will be able to store the color of unique irons around that 0, or I would say 1, because we have changed the 0 to 1. Now we will initialize the size with 1 because we have changed the 0 to 1. So this will also get added in our size. And we will iterate on the unique neighbors, and we simply add the iron size in our size, and we will take the maximum of that. Now you might return the answer this max iron only, but no, because see, if all the values are 1 in our grid, then what will happen? This will never go inside this grid ij is equals to 0, and you will return the max iron size as 0. So what we need to do in that case, if there is no 0 in our grid, so we will simply return the size of the grid. Otherwise, we will return this max iron, which you have completed just now. Okay. So I hope you get this question. This was a little bit tricky, but this was very intuitive one. I hope you get it. But if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys. See you in the next video.